Hey, this is Miss Hygra, and today we're going to do 5.6, which is fit a line to data. And today my guest speaker is
Miss Fitzgerald. Thank you for welcoming me to your program.
Okay, so we're going to start off, and we're going to fit a line to a data. And so what we're going to do is we're going to draw some scatter plots. And a scatter plot is what you can see here. It's just a bunch of dots from the points that we're plotting, and it's a graph that's going to determine whether there's a relationship between the paired data, and it can show trends in the data. So, Ms. Fitzgerald, can you show us some of the trends that you see here?
Yes, and by trends, do you also mean correlation?
Exactly. It's the same thing.
Very good. Good to know. Thank you so much for that. Well, the first picture that I see has a whole bunch of dots, which you call a scatter plot. Yes?
Yes.
Yes, thank you so much. And they tend to be increasing. The x is increasing, I'm sorry, the y is increasing as the x is increasing. So as I look at it, and if I'm thinking about the slope that we learned about in the last chapter, it's rising from left to right. This is known as a positive correlation, Miss Hygra.
Yes, because that line also has a positive slope. So positive slope goes with positive correlation.
Yes, ma'am.
So for the negative correlation here, we see that from left to right, y is decreasing, my y values are going down as x increases. So it's a negative correlation, and the slope of this line is negative.
Yep.
But this last one looks a little different.
Looks a lot of different to me. Looks like a whole bunch of random points to me, Miss Hygra.
Yes, which is why it has relatively no, and it says correlation on your paper, which got cut off here. So this has, so a lot of data, when it doesn't show some sort of pattern that flows in a line, where it's just a scrambled bunch, it has relatively no correlation.
Very good. I think I get it. Let's go on, shall we?
Okay, so what we're going to do next is figure out how to find these lines, which best fits our data. Okay, so what we're going to go through here is how we're going to write the best fit line. So in order to do that, we are going to draw a scatter plot, which is we're going to plot a bunch of dots from our table. And then we're going to look and we're going to see if it can be modeled by a line, meaning does it have positive or negative correlation. So if the dots look like in the first two examples where they follow the line, then we're going to move on to step 3 and we're going to draw a line. And we're just going to draw a line and we're going to make about as many points above the line as below the line. Is there anything else we should know about drawing a line?
Well, I try to go through at least 2 of the data points when I do it because it makes it easier for us to do it. What do you think about that, Miss Hygra?
You can go through 2 of the data points, but we don't have to. So if you can find 2, then that would be a great technique because then we have 2 points. So then when we have our 2 points, like Miss Fitzgerald suggested, is drawing it through 2 points, then we use those 2 points to write an equation for our line. Okay, so now we're going to go on with an actual example for writing a best fit line.
So the directions say make a scatter plot of the data in the table, draw a line of fit, and write the equation of the line, describe the correlation. So if you take a look on your screen, you'll see that there are some coordinates that are appearing. These are the coordinates that you see in your XY table. Thank you, Miss Hygra, for graphing those for us. So for 1, 3, she's graphing 2, 5, 3, 8, 4, 9, 5, 11, and 6, 12. If you need a moment to pause while you graph yours, go ahead and do that, but Miss Hygra and I will continue graphing ours. Looks pretty good. And notice also that Miss Hygra is labeling her points as well. It's just going to make it a little bit easier for us to keep track of what we have and where it came from. So now that our coordinates are all plotted, we have a nice little scatter plot to look like. What does this look like to you, Miss Hygra? Positive or negative correlation?
Well, from left to right, they are going up, which looks like the line's going to have positive slope, so I know it's going to be a positive correlation for the data. So when it says describe the correlation, I'm going to say positive.
I agree.
Okay, so it has positive correlation. So now we're going to go on, and we have our steps. So step 1 says make a scatter plot.
You did it. Good job.
Excellent. Number 2, decide whether the data can be bounded by a line. Well, yep.
Yep, I think so.
Looks like a line. We said it was positive. So then we're going to draw the line. So now what we're going to do is we're just going to draw a line. And you can pick 2 points to draw the line. And for step 3, it says there should be approximately as many points above the line as below the line.
Right. So if I have 3 points above the line, I want to have
about 3 below.
Right. About. Did you notice Miss Hygra said about? That means it's not always going to work out to where it's even. But what we don't want to see is 6 points above the line and only 2 below. That's not a good look.
No.
No.
Okay, so we're doing this on the computer, which is a little harder to draw a straight line. So we apologize if it's not perfect. So we're going to go ahead and draw our line now.
Right, and when Miss Hygra said it's a little bit harder, she actually meant it's a lot harder. But we are going to do our very, very best for you. So, ready, ready, ready. It's going to appear in one moment.
Okay, voila, there is our line. So we did draw this with a straight edge, as should you. I put arrows on both ends. So now looking at it, I have 1 point below, 1 point above. Is that good?
I think that's amazing. I also think it's amazing that you went through 1, 2, 3, 4 of the points. That's great. When it can happen. Doesn't happen all the time, though.
No, generally it's not going to happen. So we drew our line. So step 4 says write the equation of the line using 2 points on the line. You can pick any 2 points on the line.
Any 2 points?
Any 2 points on the line, as long as it's on the line. So let's pick 2 points.
Okay, Miss Hygra, I like this point right here.
Okay, so we made that one nice and big. And I'm going to use this one over here because it's also nice and big.
I like it.
Okay, so now we're going to write the equation for the line. So to write the equation of the line, we need to find the slope.
Yes. Hey, do I have to use a slope formula, or can I just use it by going from one point to the next?
Well, you could do either way. I think the slope triangle going from one point to the next is a lot easier.
I think so too.
Okay, so let's find the rise.
The rise. How much am I going up? How about you? Tell me when to stop.
And stop. So we went from 5 to 11, so we went up 6. Now let's run.
Sorry, I just spit. Run 1, 2, 3.
Okay, so we ran 3. So now we can find the slope.
I'm going to start with that.
Okay, so rise over run.
Yes. So rise, we rose 6. So that's my 6. And we ran 3. How's that look, Miss Hygra?
It looks great, but you're not done.
I'm not done. Why?
Does 6, can that be divided by 3?
It can, actually. 6 divided by 3 is 2. So my slope is 2. But I think I need 2 things to write my equation. I need the m and the b because it's y equals mx plus b.
Good. So we need to pick a point for our x and our y.
Which point should I choose, Miss Hygra?
Well, I like the smaller of the 2 numbers.
Which would be this one?
Yes, and the coordinates of those is 2, 5, which I can see so nicely since I wrote my scale on my axes.
Good job. Can you do me a favor and label the x and the y for me?
Perfect. Can you plug in the x and the y and the m?
Teamwork makes the dream work. 5 equals m, which you said was 2, times x, which is
2.
2. What a coincidence. Plus b. I'm writing sideways and it's a hot mess. So, Miss Hygra, what would I do now? Simplify?
Yep. 2 times 2 is
4. Plus b.
Now you need to subtract 4 to the other side.
Oh, thanks. I hadn't figured that part out yet. So 1 is equal to b. I have my slope and I have my y-intercept, Miss Hygra.
Good.
What do you think about that?
So now we need to write an equation or something, don't we?
I think so. Well, we know that y equals mx plus b. So y is equal to, instead of m, we said was 2, x plus b. But I almost wrote b. It's actually 1.
Yep.
Hey, here's the thing. I can kind of self-check this out a little bit because I'm saying that the y-intercept is 1. Looking at the graph, it looks like it's about 1. Because our line is not perfect, we do want to make sure that we calculate the b just like we just did, Miss Hygra. What do you think?
Well, I think it looks pretty good because this does look like a slope of 2. If I start at this y-intercept, which looks like 1 for my b, and I go up 2 and over 1, I land on a point. And if I go up 2 over 1, I land on a point again. So it looks like our equation matches our line.
I think it's a great line, and I think it's a great equation.
What I would like to point out to you is when you drew your line didn't necessarily go through these 2 points.
That's right.
So when you find your slope, you have to find the slope through your 2 points.
That's right.
So everyone's will be slightly different, but is that okay?
That's okay because really, although it's called the line of best fit, what we are looking for as graders is a line of good fit. Is it good? Do you have about the same number of points on the top and below? If so, that's a pretty good thing.
And is your slope about 2, and it should be a positive number since it was positive correlation, and is your y-intercept about 1 because your line should be crossing somewhere around there?
I think we did well, Miss Hygra. How about we go on to number 2?
Excellent choice. Okay, so you go ahead and read the directions and I'll start plotting.
Well, it says make a scatter plot of the data in the table. Sounds familiar, Miss Hygra. Then it says draw a line of fit. So not best fit, but a good fitting line. Then it says write an equation of the line, describe the correlation. So as you can see, as I'm talking, Miss Hygra is plotting the points. If you struggle with plotting points, go ahead, do yourself a favor, pause, and then make sure that your coordinates match our coordinates. The next thing that you will see is a line of good fit. Thank you, Miss Hygra, for drawing that lovely purple line. Looks good to me. It looks like there are about 2 points above and 1 below. I think I'm good with that. It doesn't always have to be 2 and 2 and 3 and 3. It looks like these are super duper close, and this one is out here. It looks good to me, Miss Hygra. Good job.
Thanks.
So, looks like, what was my first step? Well, first step was make a scatter plot. Check that off the list. Step 2, can it be modeled by a line? Yeah, we just drew it. And the line is drawn for step 3. So the next thing I think we need to do is write our equation. So it looks like we need our slope. Do you want to pick 2 points?
Okay, I will go ahead and pick 2 points. It goes through that point really well, and I think it's going through that point really well.
Looks great, Miss Hygra.
Okay, so we picked 2 points, and we need to find the slope of those 2 points. So I'm going to go ahead and do a slope triangle.
Love the slope triangle.
So I went down 3, so my rise is 3, is that correct?
Well, it's actually -3 because you went down.
Ooh, good catch, thanks. And then I'm going to run 1, 2, 3. I ran 3, and it's a positive 3 because I went right. I checked it this time.
Good job. So your slope is rise over run. So that would be -3/3. And I remember from last time you did ask me to reduce, and so we will. So my slope is -1.
Okay.
How do you feel about that?
Well, the line is going down, so the slope should be negative, just like my correlation is going to be negative.
It is.
Because my slope is negative and because it's going down to the right. Okay, so now I need to find my y-intercept. And my graph, it's crossing the y-axis up here, like around 1.5, 1.6. So when I find the y-intercept, I know that should be about my answer.
That is our target area.
So we're going to pick a point on the line for my x and my y, and I like this one right here because it's 2, 0, and it has a 0 in it, so it's a really easy number to plug in, and it's also a smaller number than this one over here where it has negative. So I'm going to pick that one.
Excellent choice, Ms. Hygra. I agree. However, if I didn't agree with you, no one cares, because no matter what, as long as the point is on this line, it will work in my equation. You agree?
I agree.
Awesome. So we're going to go with y equals mx plus b?
Yep.
Okay. So y equals mx plus b. Instead of y, Miss Hygra, I'm going to write
0.
And instead of m, I'm going to write?
You reduce it to be -1.
-1. And instead of x, I shall write?
2.
2 plus b. Looks good.
Well,
except something didn't show up. My y, 0. Let's try that one more time. So 0 is equal to?
-2.
Plus?
B.
Good job. And then to solve for b, I'm going to?
Add 2 to both sides.
Teamwork, making that dream work yet again. So 2 is equal to?
B.
B. I think we're ready to write our equation. I have my slope, which is -1, and my y-intercept, which is 2.
Excellent.
So y is equal to? Say it to me.
Negative x. You don't need to write that 1.
Why not?
Well, you don't need it.
Why?
Because it's implied.
Okay.
Plus b, which is 2.
Got
X
it.
in your answer. Let's make sure we answer the question. It says draw a line of fit. Oh, it's drawn. Write an equation. There's an equation. Describe the correlation. It is negative correlation. And does it look correct? So we said that the y-intercept should be around 1.5. Well, we got a y-intercept of 2. Is that close enough?
That is absolutely close enough. You did a wonderful job.
Yep. So is in the ballpark of correct. Yours will, of course, be different because you drew a different line through different points, and you found your slope through your points, and you found the y-intercept of your line.
Yes, ma'am.
Okay, well, I think that is all for tonight.
I think so, too. Thank you all. You've been a wonderful audience.
Have a good evening. See you in class.